In this tutorial video, we're going to solve some more trig equations. So let's just jump right in. I see a mixture of sines and cosines. That's not okay. We need all of one. So let's remember our Pythagorean identities. We know that sine squared x is equal to 1 minus cosine squared x. So this is something that you have memorized. So we can take this and do that substitution. So I'm just going to put that in right there. So I've got this little distributive property happening over here. So that'll give me 2 minus 2 cosine squared x. And I'm just going to bring this down, cosine x plus 2. Now let's get everything on one side. So I'm going to move these over to the left. So if I subtract 2 from both sides and add 2 cosine squared x to both sides. Now there are no like terms here, so it's going to wind up just sitting in the front. 2 cosine squared x. You can't put these together, so they're going to wind up side by side. So I'm going to wind up with 2 cosine squared x that I just brought down. And then I'm going to bring down the cosine x. Now these cancel out, so that's just going to equal 0. I'm going to factor this because we have cosine x in both places. So if I factor out that common factor of cosine x, that's going to leave behind 2 cosine x plus 1. Alright, and you could imagine doing the distributive property and you see that you would get back to what you started with. So I can finish this off by setting each one of these factors equal to 0. Oh, I'm missing an s in there. So cosine x plus 1 is equal to 0. So here, if I subtract 1 from both sides, that's going to give me 2, oh man, I'm messing up a little bit here. It's going to give me 2 cosine x is equal to negative 1, and then if I divide by 2, I'm going to get cosine x is equal to negative 1/2. Alright, just need a little bit more space. Alright, so now I'm ready to find x in both of these cases. Alright, looking at where is cosine x equal to 0? Let's look at that first. So here's my unit circle. And I'm remembering that on the unit circle, every point xy, the cosine is the x value. That's my cosine right there. So where is the x value going to be 0 on the unit circle? Well, the x value will equal 0 right here and right here because it's neither left nor right. It's right on the y-axis. So the x value and thus the cosine will be 0. So this angle is of course pi over 2. And then this angle down here, this is 1 pi over 2, 2 pi over 2, 3 pi over 2. So these are the two angles where the cosine will equal 0. So that's two answers. Okay, maybe I'll put them down here. X is equal to pi over 2 and 3 pi over 2. Okay, now where is at what angle is the cosine equal to negative 1/2? Let me draw another unit circle, another version of the unit circle. Where, forget the negative for a second. Where is cosine equal to 1/2? So everything on this chart you should basically have memorized. So I know that cosine of pi over 3 is 1/2. So that tells me that pi over 3 is the reference angle. So I'm going to draw a bunch of pi over 3's. All right, pi over 3 is a third of pi. So if I look at the top half of this semicircle, well, the top half of the circle is a semicircle, I know that that's pi, and each one of these is a third of that. So these are the three angles where the reference angle is pi over 3, because this is pi over 3. Now, two of these will be positive, and two of them will be negative. Now remember, we're talking about cosine. We're talking about x values. Okay, so x values are positive on the right-hand side, and they are negative on the left-hand side. So all of these four positions will have a cosine of 1/2, but these two will be positive 1/2, these two will be negative 1/2. In this case, cosine equals negative 1/2. So that means we want specifically these two angles, okay, because they will give us a negative 1/2. So what is this? So this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So these are two additional answers, 2 pi over 3 and 4 pi over 3. Looking at problem number 5, I see that we have cosines and sines. That just won't do. I want all of one type. So let's use the fact that we know that cosine squared is equal to 1 minus sine squared. All right, that's something that we have memorized. So this is something that I can take and substitute right here. So that's going to give me 2 times 1 minus sine squared x is equal to 13 sine x minus 5. Now all I have is the sine function, so this is much better. So a little distributive property across this guy, and I will have 2 minus 2 sine squared x is equal to 13 sine x minus 5. Now let's get 0 on one side and see what we have. So you know what? I like to keep my sine squared positive if possible. So that's why I'm going to add 2 sine squared x to both sides. That'll make it positive. So we'll have 0 on the left, which is fine. And of course I'm going to subtract 2 from both sides. So that's going to give me 0 equals, these can't be combined, they are not like terms, so I'll just write them side by side. 2 sine squared x plus 13 sine x minus 7. Okay, hopefully this can be factored. So let's go for that. 2 sine squared x can be factored as 2 sine x times sine x. Now, skipping this middle part for a minute, I'm looking at the 7. That is either going to be 7 times 1, or it's going to be 1 times 7. Alright, it's going to make a difference. So if it doesn't work out one way, we'll try it the other way. When you get good at it, you'll start to do it in your head a little bit, so you'll see where you're headed. So when I look at this, I'm thinking inner plus outer equals middle. Alright, this is the middle swerve. Okay, inner, I have 1 sine x. Outer, meaning if I multiply these two outers, then that's going to be 14 sine x. So these have to add up to be positive 13. How could that happen? If this was negative and this was positive, it would make positive 13. So for this to be negative, that means I have to have a negative 1. And for this 14 to be positive, I need a positive 7. And there you go. Also, -1 times +7 is -7, so that's important. So we factored it. Great. Now we can solve this by setting each of these factors equal to 0, like this. So I'm getting sine x by itself. Here I can add 1 to both sides, so I have 1 is equal to 2 sine x. And then I could divide both sides by 2. So that gives me 1/2 is equal to sine x. Meanwhile, over here, if I subtract 7 from both sides, then I will have sine x is equal to -7. Interesting. Let me see. Need to give myself a little bit more space. What angle will give me a sine of 1/2? Sine of what angle is 1/2? Well, that's one of those things that we have memorized. Alright, everything on this chart you should have memorized. So sine of pi over 6 is 1/2. Alright, you should have that memorized. So that tells me what the reference angle is. So looking at this unit circle that I'm about to draw, if the reference angle is pi over 6, then I'm going to draw a bunch of pi over 6's. And here's how I do it. Okay, the upper half here is pi. So I'm going to divide this top half into 6 pieces. So each one of them will be 1/6 of the pi, or pi over 6. So here I go. So I'm going to put 3 pieces here and 3 pieces over here. That'll be a total of 6. So here I go. So if I go like this and like this, alright, see how I have 3 pieces? And I'll do the same thing here. I'll go like this, and I'll go like this. Okay, it's a little crooked, but you get the idea. So you see I have 6 pieces in the top. That means each one of these pieces is pi over 6. Now, in terms of reference angles, alright, these 4 angles have a reference angle of pi over 6. Alright, because they are each pi over 6 away from the horizontal. So that means the sine of any of these is going to give me 1/2, except 2 of these will be a positive 1/2 and 2 of these will be a negative 1/2. Let's see. Remember, when you're talking about a unit circle, every point xy is a cosine and a sine. So remember that the sine of any angle is the y value. So where will these y values be positive and where will they be negative? Well, for y values, the ones that are above the x-axis are positive and the ones below the x-axis are negative. So these two are positive, these two are negative. Now in this particular case, we want a positive 1/2. So these are the 2 angles that will give me a positive 1/2. Okay, so now let's see what they are. So this first one is just a simple pi over 6. Okay, now I'm going to count my way around because this is like 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So this is 5 pi over 6. So those are the 2 angles that will give me 1/2 if I take the sine of them. So those are 2 solutions that I have. So x is equal to pi over 6 or 5 pi over 6. Now, what x values, what angles will give me -7? Sine of what is equal to -7? Well, don't be silly. Sine goes up to a maximum value of 1 and down to a minimum value of -1. Alright, that's as high as it gets. +1 and as low as it gets is -1. So there's no angle that's going to give me a -7. Okay, so this part has no solution. So these are the only answers. Okay, we're at 15 minutes. I'm going to go ahead and try to squeeze in one more problem. All right, number 6. I think I'm going to need more space, though. In problem number 6, I have two different kinds of functions. I have tangent and I have secant. That will not do. I need all one type of function. So let's see. What are my formulas? So I know that tangent squared, that's a horrible, let me try that again. I know that I have memorized that tangent squared x plus 1 is equal to secant squared x. All right, that's one of the facts, one of our Pythagorean identities. So we can do a little substitution here because secant squared x is right here, so that should equal this. So I'm just going to put that in its place. All right, so at that point I will have, let's see, tangent squared x plus 1. All right, just put that in right there. Now I'm going to bring down my plus. Tangent x is equal to 1. Okay, now I need 0 on one side, so I'm going to subtract 1 from both sides. But right away that's going to give me tangent squared x plus, because both of these cancel out, so plus tangent x equals 0. So both of these terms have tangent x, so that's a common factor. So I can factor that out. So if I factor out tangent x, that's going to leave tangent x plus 1. Alright, so I've got this. Now I can set each of these equal to 0 and solve to find my solution. So I can set tangent x equal to 0, and I can set tangent x plus 1 equal to 0. So I could solve these, see what I get. Where is tangent equal to 0? I feel like I need to do some thinking off to the side. If I want to know where tangent equals 0, it helps me to remember that tangent is just sine. I guess I should, if I'm doing x, I should stick with x's. Tangent is sine over cosine. Alright, the only way this fraction is going to equal 0 is if the numerator equals 0. Okay, the denominator can't equal 0 because that would be undefined. So the only way a fraction is going to equal 0 is if the numerator is 0. So tangent x equals 0 will have the exact same solutions as just numerator sine equals 0. So I can really ignore the tangent and just think about where does sine equal 0, because the answer to both of these will be the same thing. And okay, so fine, where does sine equal 0 then? Well, if I look at the unit circle, remembering that on a unit circle every point xy is in the form cosine comma sine. In other words, the sine is the y value of every point on the unit circle. So where will a y value equal 0 on the unit circle? Y values equal 0 on the x-axis. So that's going to be here and here. Alright, the y value will equal 0. Sine theta will equal 0. Well, this is 0 and this is pi. Okay, so x is equal to 0 or pi. Okay, because in both of these places sine equals 0, so then you're going to have sine, you're going to have 0 over whatever you got there, so that'll be 0. Now, moving on to tangent x plus 1. If I go solving this for tangent x, I'm going to subtract 1 from both sides. So I'm going to have tangent x is equal to -1. So where is the tangent equal to -1? So I'm hoping that you've memorized by now certainly everything on this chart, including the fact that tangent is going to equal to +1 at pi over 4. Okay, let's investigate that a little bit. Should I erase this or draw a new unit circle? I'll just draw it again. Okay, so consider this. Here is pi over 4. Okay, this little angle right here, this is pi over 4. Right here, the tangent is 1. Okay, so tangent is 1 here. And guess what? It's also going to be 1 here. Now the reason being is because tangent is equal to sine over cosine. So in this quadrant, both of those are positive, so you're going to get a +1. Now in this quadrant, they are both negative, and a negative divided by a negative is also a positive. But if you look at the other angle that has a reference angle of pi over 4, all right, if I look at these two, in this quadrant, you're going to get a -1 for the tangent here. That's because you have a positive sine and a negative cosine. Alright, so a positive divided by a negative is a negative. Similarly, you're going to have a -1 for this angle in this quadrant. So all of these have reference angles of pi over 4. And again, I pulled that off my memorized facts. I know that tangent of pi over 4, that reference angle gives me 1. So that tells me that any angle that has a reference angle of pi over 4 is going to give me a tangent of either 1 or -1. In this case, we want -1. So that means we want this angle and we want this angle, the two places where you get -1. Okay, so let's see. This is 1 pi over 4, 2 pi over 4, 3 pi over 4. So that's this angle right here is the angle 3 pi over 4. Let's keep going. 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So this angle over here is the angle 7 pi over 4. Okay, so the two additional solutions that we're going to get will be 3 pi over 4 and 7 pi over 4. So we have these 4 solutions to the equation. And this video is officially long enough, so let's call it a day.